Introduction. Chemical bonds are the foundation of molecular interactions and play a crucial role in understanding the behavior of matter. In this comprehensive exploration, we delve into the intricate world of chemical bonds, their types, formation, and significance in the field of chemistry. Types of chemical bonds. Chemical bonds can be classified into three major types: covalent bonds, ionic bonds, and metallic bonds. Covalent bonds. Covalent bonds occur when atoms share electron pairs to achieve a stable electron configuration. This type of bond is common among non-metal atoms and often forms molecules. The strength of a covalent bond depends on factors such as the number of shared electrons and the electronegativity difference between the atoms involved. Ionic bonds. Ionic bonds are formed when there is a transfer of electrons from one atom to another, resulting in the formation of ions. This bond typically occurs between a metal and a non-metal atom. The electrostatic attraction between positively and negatively charged ions creates a strong bond. Ionic compounds tend to have high melting and boiling points, and they often form crystal structures. Metallic bonds. Metallic bonds occur within metals and are characterized by the pooling or sharing of electrons among a sea of metal ions. This delocalization of electrons gives metals their unique properties, such as high electrical and thermal conductivity, malleability, and luster. Metallic bonds are responsible for the bonding within metal structures. Formation of chemical bonds. Chemical bonds are formed through various mechanisms, depending on the type of bond. Covalent bond formation. Covalent bonds are formed when two atoms come close enough for their outer electron orbitals to overlap. The sharing of electrons results in the formation of a stable molecule. The strength of covalent bonds can vary, ranging from single bonds, one shared electron pair, to double and triple bonds, two or three shared electron pairs. Ionic bond formation. Ionic bonds are formed through the transfer of electrons from one atom to another. A metal atom with a low ionization energy donates electrons to a non-metal atom with high electronegativity. This transfer creates positively charged cations and negatively charged anions, which are held together by electrostatic forces. Metallic bond formation. Metallic bonds are formed due to the delocalization of valence electrons within a metal lattice. The positive metal ions are held together by the electron sea, which enables the free movement of electrons throughout the structure. Significance of chemical bonds. Chemical bonds are fundamental to understanding the properties and behaviors of substances. Determining chemical properties. The type and strength of chemical bonds influence the properties of compounds. Covalent bonds allow for the formation of a wide range of organic and inorganic compounds with diverse properties. Ionic bonds contribute to the high melting and boiling points of ionic compounds and their ability to conduct electricity when dissolved in water. Metallic bonds give metals their characteristic properties, such as malleability, ductility, and conductivity. Chemical reactions. Chemical bonds are at the heart of chemical reactions. During a reaction, existing bonds are broken, and new bonds are formed, resulting in the transformation of substances. The type and strength of the bonds involved determine the energy changes and outcomes of chemical reactions. Understanding molecular structures. Chemical bonds dictate the shape and structure of molecules. The arrangement and orientation of atoms in a molecule determine its physical and chemical properties. Covalent bonds, in particular, influence molecular geometry and the presence of functional groups, which are crucial for understanding chemical reactivity and interactions. Bond strength and stability. The strength of chemical bonds determines the stability of compounds. Strong bonds, such as triple bonds, are more difficult to break and result in highly stable molecules. Weaker bonds, such as hydrogen bonds, play a significant role in molecular interactions, particularly in biological systems. Conclusion. Chemical bonds are the fundamental forces that hold atoms together, forming compounds and molecules. Understanding the types, formation, and significance of chemical bonds is pivotal in unraveling the mysteries of matter and comprehending the workings of chemical reactions and molecular structures. By delving into the intricacies of chemical bonds, scientists and chemists can unlock the secrets of molecular connections and pave the way for innovative discoveries in various fields of science and technology.